All right, hey there, welcome to this video where we're going to explore how to represent data in another type of plot called a box plot or a box and whisker plot. Earlier in the unit, we explored how to represent data, bivariate data, onto scatter plots to try to observe a trend if one exists, to see what kind of relationship there was between the two different factors. Now then after that, we looked at the measures of central tendency, and we just recently watched something about the range to try to see how spread out the data is. And the word consistency is going to come back here when we're looking at box plots, okay? Now in our first scenario for today's notes, we have that the owner of a restaurant wants to find out more about where her patrons are coming from. She gathers data about the distance in miles that people commuted to get to her restaurant. People reported the following distances traveled. So somebody who's in her restaurant traveled 14 miles to get there, somebody else traveled 6, somebody else traveled 3, and so on. Now, why might the owner want to consider this information? And if you just want to pause the video and jot down a few thoughts now, that'd be great, for why the owner might actually care to consider how far away people are traveling to get to her restaurant. So just pause it and jot down your thoughts. Now, when I think about that, my first thought is for advertising purposes to kind of see how far the reach is and to see if people are willing to travel to come to the restaurant because the food is that great. So my very first thought is obviously the restaurant owner's goal is to make money. And then after that, I'm kind of thinking about just like the ads that might be needed to draw more attention. Now you might have come up with something differently, and that's great, but that just kind of was my first thought. Now we want to organize this information into a box and whisker plot, and we have 20 pieces of data here. So to kind of help the numbers be organized, I have 20 different box spaces here. Now when we look up at the data, when we look and scan, I see the smallest number here is some 1, and we have 2 of those here. So I'm going to cross those out. Friendly reminder that that's my strategy for us to not mess anything up. And when I look at the data and I'm trying to scan for the biggest number I had seen was a 15, then here is a 22, and then here's a 30. So I'm going to go ahead and jot down the 30 as the biggest number here. After the ones, let's look for any twos. I got 1, 2, 3 of those. Boom, boom, boom. All right, now let's look for our threes. I got 1, 2, 3 of those. Okay. All right, now let's look for our fours. We've got 1, 2 of those. All right, let's see if we have any fives. I don't see any fives. Now let's look for the sixes. I got a 6. And that's it. 1, 6. All right, let's check for sevens. There was 1. Saw 1, 8. All right, now let's see. I don't think we have any 9s. Nope. There's a 10. We had an 11. Don't see any 12s. Don't see any 13s, but we got a 14 and then a 15. No 16s, 17s, 18s, but we got here no 19. We got a 20 and a 22. All right. Now you guys have not yet seen a box and whisker plot, I don't think. So let me give you guys kind of the rundown of the main pieces of information you need for a box and whisker plot. There's really 5 big things that you care about, and the 5 things are here highlighted in yellow. So the first one here is something called the lower extreme, which is basically the smallest number in your data set. And the smallest number in our data set is right here. That's a 1. The upper extreme would be the biggest number in your data set, which is right here, a 30. So if you were ever asked to identify the lower extreme or the upper extreme, really simple. It does allow you to see the spread in the data, the range. So you could do a 30 minus the 1, and that would give you the range here of 29. Now for the number that's in the middle, one thing I want to point out here when we found the mean, median, the mode, and the range back here, if we calculate here that there's 1, 2, 3, 4, 5, 6, 7 numbers, if there was an odd number of data pieces that we had a true median, See here if there's 1, 2, 3, 4, 5, 6 of them though, that it's basically going to be halfway, 1, 2, 3, and then 1, 2, 3 on the other. That's like what the middle does. It splits it in half. So a shortcut here, I know I have 20 pieces of data, so I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Halfway through the data would be right there. And I've got 10 pieces of data on this side, and I've got 10 pieces of data on this side. So 50% of the data is below my line, and 50% of the data is above my line. Now, because it's not a true number in the middle, I need to add them up and divide by 2. So I get 10 divided by 2 is 5. So the median of my data set is smack in the middle there. It's the 5. Now, if I want to know the lower quartile, y'all, all I'm talking about is the median of this lower half of data. Now, I'm going to kind of separate here with this box looking thing. All right. In here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So again, I have an even number of numbers here. So if I just go halfway, 1, 2, 3, 4, 5, if I go halfway right here, this is going to be my median, a 2.5 of this lower half of the data set. Okay. Now, if I want to know the upper quartile, it's the same thing, but now it is just for this top half of the data right here. And again, if there's 10 numbers, I'm just going to go halfway through. 1, 2, 3, 4, 5, halfway through. So if you add up 11 plus 14, that's a 25. And if you cut 25 in half, you get a 12.5. So we found the median of the upper half of the data, 12.5. So we're going to use those to construct the box and whisker plot. Down here I have a number line. And if you just want to watch me construct mine, and then maybe you can hit pause on the video and draw your own in your notes. But the first thing we're going to do is set the lower extreme at the 1 here. And the upper extreme was a 30, which was right here. Now the median we said was a 5, so the median is right here. And the lower quartile, so halfway between these values, halfway between the 5 and this number here was a 2.5. So about halfway, which is right here. And then the other one was a 12.5, which is about right here. All right, and let me just use the straight line tool. Let's make that red. There we go. And let's do another one here. And I'll go ahead and connect these. So this is called the box plot, otherwise known as the box and whisker plot, okay? And what this does is it shows the data and how spread out it is or how consistent it is. We can see here that there's a lot of data closely clustered together around here. We know that a fourth of the data was right here, and then here was another fourth. Here is another fourth, and here is another fourth. That is what the box and whisker plot does, y'all. It breaks it up into quartiles. You might now realize that this quartile, you hear quart in it, which is a 4. So essentially what we're doing is we're breaking the data up into 1, 2, 3, 4 parts. The entire graph represents 100% of the data. All of the data in here is represented from the 1 up to the 30. The median represents the middle, and so this line right here that we said that was in blue up top, that middle line, the 5, it cuts the data in half. So what that means, y'all, is that half the data is represented down here, and the other half of the data is right here. And you can see that this means that this half of the data is really spread out, while this half of the data is not. When we go back up and we look at the actual data set, we can see that this top half only goes from a 1 to a 4. That's really close together. While the other half of the data spreads out from a 6 all the way up to a 30, so there's a way bigger range in here. So I want to, let me just go back up here and let me get rid of kind of all these different things. I want to show you again that the data is meant to get split up into 4 equal parts. And let me just get rid of even that circle and even this circle. All right. So again, we have it broken up into 2 parts right here. Half the numbers are here and half is here. If I take this 50% and break it up into half, that's 25% and another 25%. Same thing happened here. We broke this in half. And so 25% and 25%. So 100% of the data is represented. And each one of these sections is called a quartile. We have 4 quartiles. The data is represented on the box and whisker plot down here. So from this 1 to this 2.5, that should be a fourth of the data. So this whisker here represents a fourth of the data, and that's from this 1 to 2.5. Look right there, 1, 2, 3, 4, 5 of our numbers, 5 of our 20 data pieces fell in that category right there. 5 out of 20 reduces to 1/4. So yes, a fourth of the data is represented right here in this whisker. Then if I look at the next chunk, I'm going from 2.5 to 5, and I'm just trying to see how many numbers fall into that little category. Again, 5 out of my 20. So in this little category from 2.5 to 5, this is another 25% of my data. Then from the 5 to the 12.5, which is this chunk right here, you can see I have another 25% of my data. And then this long whisker right here, even though it looks really long, that doesn't mean it has more numbers in this range. It just means it has a bigger range from 14 to 30. So, or sorry, from 12.5, we're going from 12.5 to 30. So this is the last 25% of the data right here. A lot of students think that because this line is much longer than this line, they think that there's more data represented over here. No, that is not the case at all. It just means that the data represented in this chunk is really spread out. Going from a 12.5 to a 30 is a far bigger spread than right here when we were going from a 2.5 just to a 5. That's why they're closer together. But from 2.5 to 5 has just as many numbers in between as this did up here. Okay. So to kind of summarize the key features of your box plot or box and whisker plot, the graph shows 100% of the data. The median is in the middle. And what that does is it means that half the data is to the left, which is this 50%. And then this 50% together is above it to the right, okay? We just said that each quartile represents 25% of the data. Each of these quartiles represents a fourth of the data. And what this does is it allows you to analyze the consistency of your data, which again means to just see if it's really closely clustered together or if it's really, really spread out like this part of the plot is, okay? So that's what's going on with a box and whisker plot. Let's turn over now to see another data set together. And what we're going to do is just explore the data sets, and we're going to construct some box and whisker plots together, and we'll just be able to look and compare the two to kind of see what we're able to get at when we look at those plots. All right. Now what we're looking at here is more class scores. We've got 2 classes here, and we've got this class has this many students in it. Class 2 is a little bit smaller. We can see the scores that students have gotten on their first math test. Now, when I count for class A, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. And what we want to do is to construct the box and whisker plot, we need the numbers ordered from least to greatest. Now, a strategy I have is to just use the box to help you organize the numbers to say, okay, I'm going to underneath this spot write the lowest number. And underneath this spot, I'm going to write the highest number. And basically, if you use kind of the spots, that means you won't miss one. All right. Now, the lowest score that I see up here is actually this 55. And the highest score I see that somebody got is right here. It's 100. So I'm going to put that in the last spot. All right, so I already took care of the 55. We already took care of the 100. Let's look for anything else in the 50s. Nothing else in the 50s. I see something here in the 60s, so I'm going to put that below here. Nothing else in the 60s. Now I'm going to look for the 70s. Here's something in the 70s, so that goes in the 3rd spot. All right, now let's look for the 80s. I've got an 80, an 83, and an 86. So an 80, an 83, and an 86. And you see what I mean about how I'm using the spots to kind of line them up so I know I'm not going to miss anything. All right, then I've got 3 more numbers here. We've got the 92, the 95, and the 98. So we've got a spot for 92. we got a spot for 95, and we got a spot for 98. Now let's look at class 2. Class 2 here, the lowest score we have is also in the 50s, but this one's a 52. And we have a couple hundreds here, so I'm going to put one in the last spot and one in the next to last spot. So we've got those scores taken care of. All right, anything else in the 50s? Nope. 60s? Nope. 70s, we've got a 71. Wow, we got lots of 70s. Okay, so 71, two 76s. We got a 78, a 79, and a 97. So we've got all of the grades organized from least to greatest to allow ourselves to kind of answer this first question at a glance, which class did better. I mean, I've got a couple of things that stand out to me as the teacher. First thing that stands out to me actually is that class 2 had 200s. I mean, that's definitely going to stand out to me for sure. When I look at the number of A's, I see that this class has 3 of them. This class right here has 4. When I look at B's, I see a solid number of B's here, and then there are no B's. So if I care about A's and B's as a teacher, I see this chunk, and right here, it's only this chunk. So kind of looking at it that way, maybe class 1 did better. When looking at the average, I wonder if we did the average of both classes, which one would be a higher average. This has a lot of things here in the 70s, and then 200s might pull it up a little bit. But I guess maybe just at a glance, I'm thinking class 1. Personally, that's kind of where I'm at right now. Let's construct a box and whisker plot and see if we can use consistency here to see if like a class kind of consistently did well versus maybe the data is really spread out. Teachers also care about that stuff as well. So let's look and see here. For class 1, we'll do that in purple because that was up above here in purple. So for class 1, the lower extreme, the lowest score was a 55. And the highest score we saw was 100. All right, let's find the number in the middle here. And actually, let me get rid of those other circles just so that they don't mess with anything. Here we go. Okay, cool. So for the first one, we said there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yes, so if there's 10 of them, we can go 1, 2, 3, 4, 5. Boop. All right, so we just cut the data in half. And since there's not one true median, we're going to add them both up and divide by 2. So 83 plus 86. And then when I divide that by 2, we get an 84.5 for the median here, 84.5. All right, now for the lower quartile, I care about the median of this set. So this has 1, 2, 3, 4, 5, meaning there will be a true median if it's an odd number, because I got 2 to this side and I got 2 over here. So the 77 is the lower quartile, and the 95 here is the median of the top half, so that's the upper quartile. All right, so let's make this box and whisker plot real quick. The smallest number is a 55, so we'll plot a point here. The biggest number was 100. 84 and a half is going to be somewhere around here. 95 is right here. And 77 would be about here. All right, so there's the box that represents 50% of the data. And then here's 25% and another 25%. So there's the box plot for the first class. All right, now let's look at the box plot for the second class. The lower extreme, the score was a 52 and the highest was 100. All right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is odd, so it should have a true number in the middle, and it does right here. We have 4 on this side and we have 4 on this side. So 78 is the true median. And now we're going to have 1, 2, it's going to be smack in the middle here. And then 1, 2, it'll be smack in the middle here. So between 71 and 76, let's add them up and divide by 2. So 73.5 is the number that's in the middle here. So 73.5 is the lower quartile. And for the upper quartile, We don't need to include the median. Remember, you don't include the median. And now you've got 1, 2, 3, 4 data pieces. So it'd be 2 on this side and 2 on this side. So 97 plus 100 is 197. And when we divide that by 2, we get a 98.5. So the reason I have this example here for the box plot is to show you guys, like up top for this first class set, if you're splitting the data in half for the median and it kind of is not a true number like that, like a true number in the middle, if you have to add them up and divide by 2, if that happens, then you've got 1, 2, 3, 4, 5 over here, and you've got a true middle versus down here, when we had the true middle, you don't include this one. You just use the numbers that are on this half and you use the numbers that are on that half. When it was like this, we included the 83 with this half and we included the 86 with that half. When you have a true median, it doesn't go with both sides. You actually ignore it and then you just find the new middle of these 4 numbers and the new middle of these 4 numbers. All right, now we're ready, I think, down here in red to make the box plot for class 2. So 52 would be about right here, a little bit less than the 55. 100 though is in the same spot. The median is a 78 for this class. The upper quartile was a 98.5. And then the lower quartile was a 73.5, so somewhere around here. All right, there's the box that represents 50% of the data. Here's 25% and another 25%, and that's the whole class. So you can see here that the box plots kind of show a similar spread overall, that the range of the scores, this is a 55 to 100, this was a 52 to 100. So if you look at it that way, both classes kind of did the same. If we look at the median, we would say that class 1 did better than class 2. If we look at this 25% of the data, though, we can see that this 25%, the top fourth of this class, had a score of 95 or better, and the top fourth of this class had a 98.5 or better. So if you look at it that way, if you look at the top part of the class, then maybe class 2 actually did a little bit better. Now let's look real quick. Let's try to find the average real quick of both of these classes. Let's do it first for class 1. I don't want to miss any numbers. There's 100 and a 98 covered up. So let me go ahead and actually do those. 100 and the 98 plus this 95 plus 92 plus 86 plus 83 plus 80 plus 77 plus 64 plus 55. So those are all of the scores added up. We said that there were 10 students in that class. So their class average was an 83. Okay. Now the other class, we had the 200s we know we started out with. Then there's a 97, then a 79, 78, a 76, another 76. We got a 71 and a 52. And if I divide that by the 9 students, that average was an 81. So looking at the class averages, the first class did slightly better. And so when we look at the last question here, it says, how can the wording of the question, which class did better, be interpreted in different ways? Again, as a teacher, it really just depends. There's different things that you're looking at, but it can be interpreted in a lot of different ways because, like I said, when we look at different parts of the data, if I want to see, like this class, for example, half the class did better than an 84.5. So that's pretty good that half the class did better than an 84.5 versus half the class here only did better than a 78. So that class did better there, but when we look at this is pretty impressive, saying that the top fourth of your class did better than the 98.5. And a lot of times when you're looking at things like applications, you immediately do go look to the top fourth. And so if we do immediately compare the top fourth of each of these classes, then maybe class 2 is starting to look like a more competitive class. So it really just depends on what you're looking for. Maybe the teacher is trying to assemble a math league team to go to a competition, and at a glance they might want to pull from class A because class A, or the first class looks like a better class. But if you look at it, this class has maybe more competition for that top fourth of the class, like I'm saying, to maybe want to pull to go be a part of that team. So anyways, this question right here, I mean, this is just really open to interpretation. Which class did better? I mean, it really just depends on the perspective that you look at this, okay? All right, now what you're going to do after this is you're going to now, on this page, you're going to practice making a box plot on your own. And then after you get done in the packet, there's going to be some work online posted for you. But that concludes this video. Thank you for watching.